Yes. Video number 3, example 3. I read the questions. Prove each of the following identities. 1. The root of 1 minus cos square theta over cos square theta is equal to tan theta. 2. 1 minus sin theta into 1 plus sin theta, everything over sin square theta is equal to cos square theta. 3. Bracket, open. Sin theta minus tan theta into sin theta plus tan theta is equal to 1. 4 Roman cosec theta. I hope this cosec is it clear?
Square.
Cosec theta minus cot theta into cosec theta plus cot theta is equal to 1. Then 5. 1 over sec theta minus 1 plus 1 over sec theta plus 1 is equal to 2 cos theta cosec square theta. So we have to prove these 5 identities. Solution. We have to prove, that is one remarkable to prove that the root of 1 minus cos square theta over to prove that the root of 1 minus cos square theta over cos square theta is equals to tan theta. So this is what we have to prove. Proof. Left hand side. So in this case, what you have to do is you start from maybe the complex side and then simplify, arrive at the simpler side. So in this case, the left hand side is more complex. So we start with the left hand side. The left hand side here is equals to the root of 1 minus cos square theta, 1 minus cos square theta over cos square theta is equals to prove. So this is the left hand side. Now, this is 1 minus cos square theta is equal to sin square theta. So I replace 1 minus cos square theta with sin square theta, because from our second formula, sin square theta is equal to 1 minus cos square theta. If you make sin square theta the subject of the formula, in our second formula, you have this 1 minus cos square theta is equal to this. So sin square theta over cos square theta, and that is the same thing as the root of sin square theta over the root of cos square theta. Simplify it. Then the root of sin square theta is sin theta. The root of sin square theta is sin theta over the root of cos square theta is cos theta. Now, sin theta over cos theta is equals to tan theta, root, which is equals to the right hand side. So we are done with that. 2. We have to prove that 1 minus sin theta into 1 plus sin theta over sin square theta is equals to cot square theta is equals to cot square theta. This is what to prove. Then proof. Again, we can start from the left hand side. Left hand side is equals to 1 minus sin theta into 1 plus sine theta over sine square theta. This is the left hand side. Now if you observe 1 minus sine theta into 1 plus sine theta, if you open, because this is the expansion of the difference of two squares. So if you expand this one, you are going to have 1 minus sine square theta. The expansion of this numerator will give you 1 minus sine square theta. Very simple. That is if you are able to recognize difference of two squares. Remember, 1 is the same thing as 1 square. So 1 minus sine square theta over sine square theta. But 1 minus sine square theta is the same thing as cot square theta. Yes? That is the same thing as cot square theta. So this is cot square theta over this is, yes, cos square theta. This is cos square theta over sine square theta. So, and that is the same thing as cos square theta over sine square theta is cos square theta. Proved. Which is the right hand side. Cos square theta. Proved. So, I feel this side.
Yes.
Now, we move to the next question. We are required to prove, that is theorem figure, to prove that sec theta minus tan theta into sec theta plus tan theta is equals to 1. That is the third. To prove that sec theta minus tan theta, to prove that sec theta minus tan theta into sec theta plus tan theta is equals to 1. So that is the next question. But to prove that sec theta minus tan theta into sec theta plus tan theta is equals to 1. Proof. Now, left hand side again. Why? Because the left hand side is more complex than the right hand side. So, as I have said, we always start from the more complex side, simplify, and then arrive at the simpler side. So the left hand side here is equals to sec theta minus tan theta into sec theta plus tan theta. This is the left hand side. So here, what do? We expand. I expand. Again, this is a case of difference of two squares. If you can observe it, this is the expansion of the difference of two squares. So now, if we open the bracket and expand, this will be sec theta times sec theta is going to be sec square theta minus tan square theta. The expansion of this will give you this, sec square theta minus tan square theta. But what is sec square theta? We do know what sec square theta is. Sec square theta is equals to, I replace this sec square theta with 1 plus tan square theta. This 1 plus tan square theta is equivalent to this sec square theta. Then minus tan square theta. Then I cannot now open my bracket. So this is 1 plus tan square theta, 1 plus tan square theta, minus tan square theta. And tan square theta will cancel tan square theta, so I'm left with 1. Proved. Remember, this one is equal to the right hand side. So that is proved. Then 4. We are to prove 4. We are to prove that cosec theta, in fact, similar to the other one, we are to prove that cosec theta minus cot theta into cosec theta plus cot theta is equals to 1. Again, the left hand side is more complex than the right hand side. So we start from the left hand side, simplify, and then arrive at 1. Proof. Again, the left hand side is equals to cosec theta minus cot theta into cosec theta plus cot theta. This is the left hand side, so I simplify this. Again, if you can recognize it, this is the expansion of, or the factorization of a difference of 2 squared. So the expansion of this will give us that difference of 2 squared. Expanding this, I'm going to get cosec square theta minus cot square theta. So what do? I replace this cosec square theta with 1 plus cot square theta. Now I can clean this side. So, what am I saying? From there, okay, just for avoidance of doubt, let me repeat that line. Cosec square theta minus cot square theta. So what I do, from my formula, the 4 trigonometrical formula, this cosec square theta is equals to 1 plus cos square theta. I replace this cosec square theta with 1 plus, I open bracket, this cosec square theta is equal to 1 plus cot square theta minus this cot square theta. Opening the bracket, so I have 1 plus cot square theta minus cot square theta. This cos square theta will cancel minus cos square theta, and we're left with 1, which again is equal to the right hand side. So the identity is proved. Now, the last one, number 5. We are to prove that 1 over sec theta minus 1 plus 1 over sec theta plus 1 is equals to cos theta cosec square theta. So to prove this again, I start with the left hand side, that is proof. Left hand side. The left hand side here is equals to 1 over sec theta minus 1 plus 1 over sec theta plus 1. Here the left hand side. So here, what do I do here? I take the LCM. So this is the same thing as the LCM is sec theta minus 1 into sec theta plus 1. Again, this is the factorized the factorization of a difference of two squares. So this is the LCM. This is the LCM. This is the LCM. This is the LCM. So sec theta minus 1 into this expression is going to be sec theta plus 1. Then plus sec theta plus 1 into this LCM is going to give me sec theta minus 1. So what will happen? Plus 1 will cancel minus 1. And sec theta plus sec theta is 2 sec theta. So that is going to give me 2 sec theta over, if I expand this one, if I expand the denominator, I'm going to have sec square theta minus 1. Sec square theta minus 1. So that is going to give me sec square theta minus 1. Now, how do I can introduce a negative sign here. This is going to be 2 sec theta over minus 1 into 1 minus sec square theta. 1 minus sec square theta. Yes, I think I can write that. And 1 minus sec, recall that 1 plus tan square theta is equals to sec square theta. Is equal to sec square theta. Then if I make tan square theta the subject of the formula, I have tan square theta is equal to sec square theta minus 1. So now I can still leave it the same way it is here. No need of writing it. So I can leave it the same way it is. So that 2 sec theta over this sec square theta minus 1 from here is tan square theta. What am I saying? I replace sec square theta minus 1 with tan square theta. So that I am now going to have, this is the same thing as 2 sec theta times 1 over tan square theta. So, and then what is sec theta? Sec theta 2 cos theta sec square theta. So now, let me clean this up first. So, now, this is the same thing as 2 times 1 over cos theta, 2 times. So, now this is the same thing as 2 times 1 over cos theta times, that 1 over times square theta is the same thing as, this is cos square theta. That is the same thing as cos square theta. So that is the same thing as 2 over cos theta times cos square theta, the same thing as cos square theta over sin square theta. Now, cos theta will cancel 1 cos theta here. So the square of the cos theta will go. Then what am I left with? So I will be left with this 2 cos theta over sine square theta. 2 cos theta over sine square theta. But 1 over sine square theta is cosec square theta. So this is equals to 2 cos theta times cosec square theta. Proved. Think I'm done. I think that's what you have to prove, yes?